Hey guys, this is lecture video 9 of CSE2000Q2S Computer Science 2, taught by Lawrence Orijuela, and my name is Lawrence Orijuela. Today we're going to talk about operator overloading, okay? So today is October 31st, 2020, which is a Saturday. So, yeah. Unfortunately, this video ended up getting posted a day late because, well, I'm sure you saw the emails already, but on Tuesday, CSUSB experienced an entire campus-wide blackout. And because my apartment was right across the street from campus, I got affected by that too. So I was without power for an entire day. And when the power came back, I was actually without internet for a following day. So there were 2 days straight in which I just couldn't work on anything. And because of that, I fell really far behind in not just this class, but also the other classes that I'm a part of. But I caught myself up, but it was actually because of that I just couldn't make a lecture video Friday morning, and now I'm making this lecture video today. So if that inconvenienced anybody, I'm very sorry about that, but it just happened. And me teaching this class has been a real learning experience for me, because I'm really going out of my way to prepare these lessons in a way that I would teach them if I was an actual computer science tenure track professor, which I will be one day after I get my PhD. And this whole thing has been a really big learning experience, and I'm grateful for that. And I'm also grateful to you guys for being my students and sticking around with me for this long. It's been it's been a real journey, right? But anyways, let's get down to business and look at our tentative schedule. So, as you can see, this week we are discussing overloading, and your activity 7 is due midnight tonight because I gave you guys an extra day because of me being late. And as you can see, I made one slight change to the tentative schedule. Your lab 3 used to be due on November 13th, but I actually decided to push it to November 20th because I want to use the 13th as a Zoom meeting day to help resolve any errors that you might have in trying to assemble Lab 3. Even though I don't think it's going to be particularly hard, assuming you did lecture activities 6 through 8 correctly. And, on that note, here's my disclaimer again. So, as mentioned in the previous lectures, we were taking 4 weeks to talk solely about classes. And because we're on week 10 right now, this is the last week we'll be talking about classes. And this is what we're going to be doing. We're going to be writing overload functions for student type.h and faculty type.h. And after that's done, we will officially be finished talking about classes. Okay? Because classes are a really, really heavy subject in C++. And now that we're on the final week of talking about classes, the following weeks are just going to be going to be easy from there. It's going to be, we're on the home stretch right now, because after this, we're going to talk about recursion, and then we're going to take 2 weeks to talk about searching and sorting, and then that'll be it. And then after that, you got your final to do, and that'll be the end of this course. So anyways, there was actually a couple things that I wanted to discuss about the midterm. So, overall, I am very, very happy with the scores of the midterm because an overwhelming majority of the class received scores of 100% or greater. That's really impressive. So, I am very happy with that. And as for your final exam, I'm going to try to post it on November 27th so that, just like the midterm, you'll have 2 whole weeks to do your take-home final before it's due on December 11th. So yeah. And but yeah, overall, I am very, very happy with the scores of the midterm. All of you did an excellent job. I'm very, very proud of you guys. And one final note. I don't know if this only applies to some of you, but on the back of the midterm, there was actually an extra credit question. I'll pull up the midterm right now. So this was your midterm, right? So there was an extra credit on the midterm that was worth 10 points, which is an entire letter grade. And it involves no coding at all, okay? All that it involves is you write a couple sentences explaining what something is. And if you did that, I gave you an entire letter grade of points, okay? I was really surprised to see that not that many students did the extra credit question, because for many of you, a letter grade would have made or braked a lot. So I was a little bit surprised that not that many people did the extra credit question. And on that note, your final exam will contain 3 extra credit questions, not just 1. And once again, they will involve no coding and just writing sentences. So make sure you look at the back of your final and do the extra credit questions, okay? But anyways, and one more thing that I'd like to discuss is this. So Zoom meeting times for the remainder of the semester. So as mentioned before, we're going to have a Zoom meeting on November 13th from 12 to 12:50, and it's a Zoom meeting for Lab 3. And this note here, I already mentioned this. Lab 3 due date has been moved from November 13th to November 20, so that you have an extra week. And the purpose of this Zoom meeting, if for some reason your person type.h, your student type.h, or your faculty type.h as errors, please use this meeting to consult with me. We will resolve your errors, okay? And then, so that's the first Zoom meeting. The last Zoom meeting is going to be held on December 4th. And this is a Zoom meeting for the final exam. And then for those who need help on Lab 4, we're going to take that time to discuss Lab 4 as well, okay? So Lab 4 has not been posted yet. And because I haven't gotten around to that yet, but I'll get to it eventually. But Lab 4 will involve no coding and just writing sentences to demonstrate your understanding of certain concepts regarding searching and sorting, okay? So Lab 4 should be the easiest lab of all because there's no coding and you're just writing sentences. So I don't think that too many people will need help with Lab 4. And that's why I decided to bunch it with the Zoom meeting for the final exam. Anyways, your practice final has already been posted on Blackboard, and I can pull it up right now, actually. So if I go over here on my second monitor. Okay. Oh, I gotta do this. Here we go. So this is your practice final. And here are the questions of your practice final. The final will consist of 3 subjects only, which is classes, inheritance, and actually, I think that's it. So yeah, your entire final will be dedicated to writing 2 classes, okay? And this will be extremely similar to your real final. So make sure you take time to look at this. And on that note, I will be posting your real final within the following weeks. During this meeting on December 4th, we will do the same thing that we did with the midterm. You will vote as a class which question you feel is the hardest, and we will do it together, okay? And this is also on top of me dropping your first question on the final. And on top of that, you have 3 extra credit questions on the final. So just like the midterm, I expect a huge majority of the class to do very well on the final. Okay, so November 13th and December 4th, those are our 2 Zoom meetings. Mark your calendars or something. Okay, in case you do need to attend either of these meetings. Okay, but anyways, we can dive into the lecture material now. So operator overloading. So thus far we have learned structs and classes in gory detail. Okay, now when we declare a new struct or a class, the C++ compiler recognizes it as a valid data type. Okay, now the reason why operator overloading is important is because if we use structured data types like this often, well, depending on the manner in which we use them, it may be important to learn operator overloading. Okay, so getting to it. Now, you might be wondering what operator overloading is. Okay, well, a better question to ask before that is, what is an operator? Now, operators, we've actually been using them already. So operators are symbols that tell the compiler to perform specific mathematical or logical operations. And we've used most of them already, right? There's the mathematical operators, add, subtract, multiply, and divide. There's comparison operators. Well, I have tables that show you later, but anyways, operators that C++ recognizes generally fall into 6 categories. Arithmetic operators, relational operators, logical operators, bitwise operators, which we don't really use that much, assignment operators, and miscellaneous operators. Okay? And all of these operators, they can be categorized more broadly as either binary, which accepts 2 operands, or unary, which accepts just 1 operand. Okay? Now, keep these 2 terms in mind because they're going to be important. Binary, which accepts 2, and unary, which accepts 1. Okay? So, these following slides, I actually prepared a couple tables showing some, but not all, of the operators that C++ recognizes. And over here on this table, we have the arithmetic operators. So we have the plus symbol, which you already know what it does. It adds 2 operands together. But another thing that the plus symbol is used for is if you wanted to concatenate 2 strings. So the plus symbol can actually be used on ints and strings, right? We have the minus symbol, multiply, divide, mod. We know all these already. We have the plus plus operator, the minus minus operator, and here are actually all of the arithmetic operators that C++ recognizes. Okay, so if I could draw your attention over here, so on this column here that says operands, so as mentioned before, operators are usually either binary or unary. Okay, now when it comes to the plus operator, it requires 2 operands, like 1 before it and 1 after it. So because the plus symbol accepts 2 operands, it would be considered a binary operator. Okay, the same is true for the minus sign because it takes two operands. Multiply, divide, mod, they all take 2 operands. So all of these here would be considered binary. On the other hand, these arithmetic operators, which are these other arithmetic operators, which is the plus plus and minus minus symbol, they are considered unary because they only accept 1 operand. So plus plus and minus minus, they both actually have 2 forms. One where you put plus plus in front of it, and then plus plus behind it. Even though both of these actually accomplish the same tasks. C++ recognizes them as two different operands: pre-increment, post-increment, pre-decrement, post-decrement. And that's why I decided to list them twice, because technically speaking, that's the correct way to do it. And anyways, so here are your arithmetic operators. Over on this table, I listed all the relational operators. So we have equals equals, which accepts two operands, and this is a relational operator that returns true if both operands equal one another, and false if otherwise. Okay. And then we have the do not equals operator, which returns true if operand 1 does not equal operand 2, and false if otherwise. Then we have greater than, less than, greater than equal to, and then less than equal to. I think those are pretty self-explanatory. And one other note that I need you to recognize about relational operators. Well, we've been using them already, right? But one thing I need you to know is that all relational operators are binary. So all of them accept two operands, okay? So here's your arithmetic operators, here's your relational. And moving on to the next slide, we have logical operators as well. So the ampersand means and. So it accepts two operands. Both of them have to return a true or false statement. So having this and, it returns true if both operands equate to true, or false if otherwise. We have the or, which you already know it does, and then we have not, which reverses the state of the operand. And one thing I need you to note is that these two, because they accept two operands, they're considered binary, and because the not operator accepts one, it's unary. Okay. We also have the bitwise operators, which is and, or, and XOR. We don't use these very often, but I decided to list them there anyways, in case you need to see it. And then we have the assignment operators, which are also all binary. So we have the single equal sign, which is the simple assignment operator. We've been using that this whole time when we said things like int x equals 5 or int y equals 10 or something like that. We have the add and assignment operator, which is the plus equal sign. It adds right operand to the left operand and assign the result to the left operand. And then we have the subtract an assignment, multiply an assignment, divide an assignment, and modulus an assignment. These are very straightforward. If you want to pause the video and read it, you can. But anyways, this next table, here are miscellaneous operators, which are operators that couldn't fall into any of the other 5 categories. So they're all just listed here as their own category, miscellaneous. So all of these operators we actually use already. So we have the dot operator, or the member access operator, and you already know what it does. It allows us to access member variables or member functions of a class or a struct. We have the pointer to member operator, which we actually didn't use at all. So I'm not going to talk too much about this. We have the scope resolution operator, which is this double colon. And it defines a function outside of a class. You already knew this. The conditional operator, we didn't really use that much. Nor did we use the size of operator. But two operators that we did use is the address of operator and the dereferencing operator, which is used for pointers, if you remember that. So anyways, that was a very, very quick and brief review over all of the different operators that C++ recognizes, okay? So now that we know what an operator is, and there's lots of them, right? Now we can answer this question about what operator overloading is. So take into consideration these two screenshots here, okay? And both of them uses the comparison operator, which is this double equal sign, which is actually all the way over here. So the comparison operator, it's a relational operator, which is binary, right? So if you look back at this code, let's actually look at the first one first. So I declared an int a, which is 15, and int b, which is also 15. And here's me using the comparison operator for ints, okay? So if a equals b, if 15 equals 15, which is true, it'll see out a and b are equal, okay? And because they are equal, it would see out this. But if they weren't equal, this code would be ignored, and this else statement would be defaulted to. And it would say a and b are not equal, okay? So that's the comparison operator for ints, okay? Over here on the right is the exact same thing, but for strings instead. So I said string a equals cat and string b equals dog. So if a equals b, and obviously that's not true, cat does not equal dog, it would see out string a and b are equal, but because that's not the case, this code would be ignored, and it would see out strings a and b are not equal instead, okay? So that's the comparison operator. It applies to pretty much any data type that you can think of, int, double, string, char, so on and so forth. But one thing that you should consider is could we use the comparison operator for data types that we wrote, like structs and classes? Like, for instance, in lecture activity 6, we created a struct called store item, which consists of 3 items, which is a string, a double, and an int, right? Consider, can we use the comparison operator to see if 2 store item objects are the same? And the answer is no, unless we overload the comparison operator to apply to struct store item. So this is what operator overloading is used for. So this example here that I have on the right, this is actually the same principle as these other 2 examples that I had for int and string, except this time it's for store items, see? So over here in this code, I actually tried to repeat the same structure. If item A equals item B, store items A and B are equal, else they're not equal. Now, as you can see, you see this red squiggly line here? That's actually an error. You see, I'm not allowed to use this operator for the data type store item because overload functions don't exist for them yet, but I could write them if I wanted to, okay? That's what operator overloading is, okay? Operator overloading is the process of extending the definition of operators so that we can apply them to structs and classes that we define, okay? So syntax for operator overloading structs or classes are different, okay? So I think the best way for me to present this material is for me to go over operator overloading for structs, and then I'm going to talk about operator overloading for classes, okay? So, all of this I said in the previous slide, but the only thing that's new is this part. So, operator overloading functions are considered member functions of a class or a struct. So, very important to keep in mind, operator overloading functions, they're functions, okay? The same way constructors are functions, the same way member functions are functions too, okay? And this is just another one of the subjects that we have to cover when we're talking about classes, okay? So, so it's about time that we can start coding and start doing our lecture activity 8. So over here on the right, I have the syntax for overloading relational operators for a struct, okay? Now, keep in mind, relational operators, that's just one of six categories of operators that we have. But yeah, this is a syntax for relational operators. So because relational operators always return a true or false statement. The data type here, because it's returning true or false, we would have to have the data type be equal to bool. And then we say the keyword operator, and then this pound sign here. Over here in my notes, I said that this pound sign is in the place of the operator in which we used to overload. So if you actually went back to the table, because we want to overload the comparison operator for structs, this double equals would take the place. It would take the place of this pound here, and then we say the struct name, and then the name of the other object. So as always, because relational operators are binary, they accept two operands, one before it and one after it. Okay, so the one before it is the one that we're on, and then one after it we have to give it a name in order to reference it. So that's why I have name of other object here, and I actually listed that here on number 2 in my notes. So all relational operators are binary with precedence from left to right. To reference left operand members, you use the code for the member variable, and then to reference right hand operators members, you have to say the name of the other object, which is this, and then use the dot operator to access member variables. Okay, well, this will make better sense when we actually do the activity. So I'm gonna get out of here, and I'm gonna open Visual Studio right now. Let's create a new project, empty C++ project. We will call you lecture activity 8. Okay, and we will save this in the same place where we saved all of our lecture activities. Okay, so add a main.cpp. Perfect. And I'll make this bigger so you can see it. Let's include our typical C++ jargon. So I'm going to include IOStream using namespace standard int main return 0. Great. So let's try to recall what we're doing. So we need to, so lecture activity 8 part 1a says overload the comparison operator so that it may be used on the struct store item. Okay. So so actually the first thing that we need to do is go back to our lecture activity 6 and copy and paste the struct that we made for store item before. Okay. So open File Explorer, which I have right here. Go to where you saved your lecture activity 6, and let's just open it very briefly. Okay, and well, I'm going to zoom out so you can see it, but if you recall, all of this is our struct store item. So we had 3 member variables, right? Item name, quantity, and price. We had a default constructor, a constructor that accepts all 3 parameters, and a constructor that accepts just string and int. So what I'd like you to do is copy the entire struct store item. So copy that, close lecture activity 6, and paste the store item code between your using namespace standard and your int main, like that. Okay. So now we have struct store item. Okay. All this. And now I'm going to go over here to the int main, and I'm going to, I'm going to break this up into sections just like we did before. Okay. So I'm going to say cout. This is part 1a, right? Yeah, it is. So 1A. Overloading the comparison operator for struct store item. Okay? Like that. So, in order for us to do this, well, actually, first I'm going to do one thing. Before we actually write the function, I'm going to write the code that's going to use it. So, I'm going to declare two different store items. So, store item, let's call it item 1. Now, I'm going to call the parameter constructor and fit all three of my variables, item name, quantity, and price in one line. So, let's call this item shorts, okay? How many do we have? Maybe we have 5 in stock. And the price for it, let's call it $15, like that. And then I'll declare a store item 2. And for the sake of example, let's make the parameters exactly the same as item 1. So I'm just going to copy these 3 and paste them inside these parentheses. So now here's what I'm going to do. I'm going to copy the same code that we saw in the previous examples. So I'm going to say if item 1 equals item 2. Now, as you can see, this double equals here, it's an error. See? No operator equals matches the operands. It's an error because I didn't overload this comparison operator yet, but we'll get to that in a moment. So here in this if, I'm going to say cout. If this happened to be true, we'll say item 1 and item 2 are the same in line. And if it's not true, this else statement will execute. Cout item 1 and item 2 are different. Like that. And then after this, I guess I'll give myself a little space. Cout and line. Now, as I said before, this is an error. I actually can't use the comparison operator on 2 store items because I didn't overload it yet. And as a matter of fact, if I ran this right now, it'll tell me I can't do it, right? Yeah. And if I look over here in my errors list, it'll say no operator equals matches these operands, or binary store item does not define this operator or conversion type acceptable. Yeah. So in short, I need to overload this. And in order to overload this, I'm going to be adding a new function to my store item struct, okay? Now let's reopen our PowerPoint. Let's see what the syntax is. So because equals is a relational operator, I'd be using the syntax. Keep these notes in mind. So the way I say it, I'm going to say bool operator, and in place of my pound, I'm going to say equals. And I have the struct name, which is store item, and then name of the other object, which is what I'm going to pronounce. So I will go back to Visual Studio, and I'm going to make a comment here. This is the overload function for the comparison operator. Okay. So if I followed my syntax here, bool operator equals. So I'm going to say bool, because remember, all functions have to have a data type, which is going to be equal to the object that they're returning. Because relational operators return bools, I have to have it be of type bool. And then I'm going to say operator, and then I have to say the operator in which I want to overload. So equals. And then I have to have my struct name. So store item. And then I need the name of the other object, because remember, relational operators, they are binary. They take 2 operands, okay? So I'm going to put a comment here. So whenever I use the relational operator, it's going to be in the form something. Well, let's do this comments. Something equals something, okay? This is operand 1, this is operand 2. Operand 1 is always referenced, but I need a name to reference operand 2. So let's give operand 2 a name. I guess a good name to call it would be other. That's how I usually name the parameters in my overload functions. I call it other. So whenever this occurs, here's what I want to do. I want this function to return the value true if item name, quantity, and price, if they're all of them the same, okay? So here's how I would approach this. I'll have an if statement here. If item name equals, and this is the comparison operator here, if it equals other dot item name, and I'm gonna use the and operator. So the double and is actually a logical operator, so returns true if both operands equate to true, right? So if item name equals other dot item name and quantity equals other dot quantity and price equals other dot price. So if each one of these variables match, this will return true. But if it's the case where none of them are right, or at least one of them isn't right, I'm going to have an else. And I'm going to say return false. So I want you to take a moment to try to understand what's happening here, okay? So I have item 1 and item 2. So item 1, because I'm going to go back to the PowerPoint and so from left to right, to reference the left-hand operand members, you just use member variable. So that's why I have item name, quantity, and price sitting on their own, because I don't need to reference it because that's the first operand. But I do need to reference the second operand, and that's why I have this other here. So item 2 is passed to other. Item 1 isn't passed anywhere because I'm referencing it directly with these. So in order to compare them, I have to say other, and then the member access operator, and then item name, other member access operator, quantity, other member access operator, price. Okay, so if all 3 of these equal one another, we should find that this if statement here should see out item 1 and item 2 are the same. And as you can see, because I defined this overload function, this actually isn't an error anymore. So I'll run this and it'll see out item 1 and item 2 are the same. Yep. So now item 1 and item 2 are the same. Now, what if it was the case where they weren't the same? Like for item 1, let's say I said shirts instead of shorts, right? What would happen as a result of me doing this is that item name equals shirts and other dot item name equals shorts, and because those are different, this automatically breaks this condition, and this else is defaulted to instead. So what should happen now is that it should see out item 1 and item 2 are different. Item 1 and item 2 are different. Yep, that's exactly it, because shirts and shorts are not the same, okay? Now, I can do the same thing if I decided to change one of this. Like, if I change this to 16 instead. Yeah, they're different, right? All right, so I think you get the point. So I'll change this back to 15. I'll change this back to shorts. Okay, so that was lecture activity 1A, where we overloaded the relational operator, okay? Now, keep in mind, this is the syntax to overload relational operators for a struct. There's syntaxes for all the other different operators as well, but more on that later. So let's go back to the PowerPoint. So now, if you go back, this was for relational operators, right? For a struct. Now I'm going to talk about overloading arithmetic or assignment operators for a struct. So for binary operators, which, if you recall, are operators that take 2 operands, operand 1 and operand 2 don't need to necessarily be of the same data type. And this is usually the case for arithmetic operator overloading. And in order for me to do that, if you look at the syntax here, overloading arithmetic or assignment operators for struct, we have struct name, and then the dereference, the address of operator, and then operator pound, where pound is in place of the operator we wish to overload, and then the parameters list. And then we have some statements here, and then the last line of code in the statements is a line that says return star this, okay? Now, to explain what all of this is, for arithmetic operators, you may need to use the dereferencing operator and the keyword star this. So, in case you didn't know, every object of a struct or a class has a hidden pointer variable pointing to itself. And the only time you would really use it is if you were writing overload functions, okay? Now, some of the time you might have to use this syntax, okay? So, by using the address of operator in the definition and using star this, we can have an object change itself directly, okay? So, that's what this is, okay? If you look at my notes, I said here, for unary operators, which is operators that only take 1 operand, the parameter list is usually empty. But for binary operators, the parameter list contains the second operand, okay? So keep this syntax in mind, because we are going to do the next part of the lecture activity, which is overloading the add and assignment operator, which is the plus equal sign for store item, okay? The second operand will be an int a, and the result of us overloading this is that the quantity is increased by a, okay? Now, if you look at this, the and assignment operator, let's go back to the tables and see what kind of operator it is. And an assignment. So as you can see, it's an assignment operator, which means that we would have to use the syntax. And then for lecture activity 1C, we're using the pre-increment operator, which if you go back to the tables, where is it? Here it is. So this is an arithmetic operator. So we have 1 that's an assignment. So 1B is an assignment operator. 1C is an arithmetic operator. So both of them would use this syntax, okay? So let's go back to Visual Studio and pick up where we left off. So here is the overload function for the comparison operator. We're going to write 2 new overload functions for this struct, okay? And one of them was the overload function for the add and assignment operator. And then we have to make another overload function for 1C. Overload function for the pre-increment operator. Well, it's good to be consistent, so I'll say that this is the comparison operator. The add and assignment is the plus equal sign. The pre-increment operator is the plus symbol. Okay. So following this syntax here, I would have to say struct name ampersand operator, and then in place of the pound, I say the operator. Okay. So add an assignment. If you go back to the tables, add an assignment. It's a binary operator. So because it's a binary operator, I'm looking at part 1D right now. Because it's binary, the parameter list would have to contain the second operand. Okay. So I will use this syntax here. So I'm going to say store item ampersand, and I'm going to say operator, and then in place of the pound, I have to say the operator in which I wish to overload. So plus equals, and inside of this, now because the second operand needs to be an int a, inside of this parameters list, I'm going to say int a, like that. Okay. Now, I'm going to scroll down here and make a new section for part B. 1B. Overloading plus equals for struct store item. Like that. Now here's what I'm trying to make it do, okay? So if I said, I'm going to use item 1, which is shirts 5 and 15. So item 1. I want to use the plus equals operator and then put an int here, which is going to be passed to a. So I'm probably going to say 5. Actually, let's use 10. Why not? So what I'm trying to make this do, well, as you can see, it's not an error right now because I have this here. But if I commented this out for a brief second, it'll tell me that I can't do this because it's an error. And I have to write an overload function for it, okay? So what I'm trying to make this do is add 10 to quantity in this brief little line of code. Now, I could accomplish the same thing by saying item 1.quantity plus equals 10. But if I wanted to make this a little more brief and just saying this, I would have to overload this, and that's, in essence, that's really what operator overloading is. We're extending the definition of these operators so that they apply to structs and classes that we write, okay? So I'm going to go back here. I'm going to uncomment this out. I have to say my struct definition. So you already know what I'm trying to do. I'm trying to add a to quantity. So, and that's very easy. Because the left-hand side doesn't need to be referenced, I can just call its member variable, which is quantity. And I'll say plus equals a. And now, this is very important. I have to have return star this at the end, okay? Return star this. Now, the reason why I have to do this is because, do you see here in in the store item, I have this address of operator here. What this means is that I am returning the address of a store item object, and because of that, the thing that I need to return is it has to have the dereferencing operator in front of it. And as I mentioned before, this keyword it refers to the object the pointer that's pointing to itself, right? So I'm gonna have that there. I'm gonna save this, and then which means that I'm allowed to do this now. So I'm gonna have a new. Here's what I'm gonna do. Before this line, I'm gonna say cout. There are this many shorts. And I'm going to say item 1 dot quantity. Like that. And then I'll cout, just to demonstrate that this is working, I'll say this line of code adds 10 to quantity. There are now this many shorts. Item 1 dot quantity. And what we should see as a result of this line of code executing is that quantity has been increased by 10. So it used to be 5 before. We should see 15 now. So it used to be 5, but after we did this line of code where we operator overload the plus equals operator, it changed from 5 to 15. Okay? So that's part 1b. Now we need to do 1c. Well, let's end the line here. And then let's go back to the PowerPoint and see what it asks of us. Now we need to overload the pre-increment operator, which uses this again, okay? Because it's arithmetic. Now because plus plus is unary, we actually don't need any objects in the parameters list. So the parameter list is going to be blank for this particular overload function, okay? So I'm gonna go back. Let's write the overload function for the pre-increment operator, okay? So I'm gonna do a similar thing to this. So I need to say store item ampersand operator plus. Now because it's unary, my parameters list can be empty. And now all that I want this to do is overload this so that when it's used, quantity is incremented by 1, okay? So I'm going to say quantity plus. And then, as always, I'll say return star this. Like that, okay? So it seems to me that for part 1c, we're going to have code that's similar to this. So here's what I'm going to do. I'm going to copy this, but change a couple things. So this is actually part 1c. We are overloading the pre-increment operator. So I'm going to say that. Pre-increment operator. Over here, we overloaded the add and assignment. Okay. And what we should be doing is that instead of using this one here, we should use plus. So now because it's the pre-increment operator, I have to put it in front like that. So at this line, there's 15 shorts, right? But after this executes, we should find that there's 16 now, because this calls this overload function here, and it increments quantity by 1, okay? So if we do that, yep, so there were this many shorts, now there are this many shorts. So there were 15, but after we incremented it, there's 16 now, okay? So that I just demonstrated how to overload the comparison, how to overload a relational operator, how to overload an assignment operator, and how to overload an arithmetic operator, okay? Now, I'm going to tell you the truth about operator overloading, because it's one of those really it's one of those subjects of C++ that's really overwritten. And here's the truth: there are various syntaxes for overloading various operators, like binary versus unary, struct versus class, arithmetic versus relational, or any of the other 4 types. And the truth is, we can't cover all of them, okay? Like, I can try to, but it just wouldn't work, because there's just... C++ is a huge subject, and I just can't show you everything. So I really have to nitpick and show you all the things that I need to... I feel like it's important. So, yeah, so, to be honest, this lesson is actually incomplete, because there are syntaxes for overloading all sorts of different operators, okay? Now, that's why it's nice to, like, have a textbook or have some kind of reference in case in your coding career you might need to reference old, like, if you need to overload operators, you have to have some kind of reference, okay? Now, even though operator overloading is powerful, there's a couple restrictions, and I listed a couple of them here. One, you cannot change the precedence of an operator, okay? Now, what I mean by precedence is like for these mathematical operators, do you know that, I think I discussed this before, but in arithmetic, you know that multiply and divide always come before add and subtract? That's always true. You can't overload an operator to change precedence, okay? You also cannot change the associativity of an operator. Now, what associativity means is, like, associativity applies more for binary operators. Like, a good example, if I went back to one of the other tables. So, so take for example, the division operator. So it divides operand 1 by operand 2. So by associativity, it means that operator 1 is done first and then operator 2. I can't switch them around so that operator 2 divides operand 1. That's what it means by associativity. And plus, why would you want to do that anyways? That doesn't make too much sense. But yeah, I just thought I'd share that with you. And then next, default parameters cannot be used with an overload operator. You cannot change the number of parameters that an operator accepts. So if an operator is binary, you can't convert it to unary. If an operator is unary, you can't convert it to binary. That's what it means, okay? You cannot create new operators. You can only overload operators that exist, okay? And then lastly, some operators cannot be overloaded. This includes, but is not limited to, the dot, which is the member access operator. This operator here, which I don't use very often. You can't overload the scope resolution operator, and you can't overload any of these operators either, okay? But anyways, yeah. Oh, and one other note that I need to discuss about operator overloading. The C++ compiler, it automatically overloads the simple assignment operator for you whenever you create a new struct or a class. And the reason why it does that is because the simple assignment operator, which if you go back to one of these tables, it's the equal sign. Because of how often it's used, the C++ compiler automatically overloads it for you. So I'm going to go back to Visual Studio. I'm actually going to demonstrate that here. So if I actually declared store item C and passed nothing to it, and I said item C equals item A. Oh, my bad. I was using numbers, so I should actually call this 3. If I said item 3 equals item 1, and then I see out the contents of item 3, it should say shirts or shorts. Yeah. So because item 1 dot item name equals shirts, and I set item 3 equal to item 1, item 3 dot item name it was equal to shirts too. So all of this was copied into item 3. So the simple assignment operator, C++ automatically overloads it for you, like behind the scenes. So there's actually no need to write overload functions for the simple assignment operator, unless you wanted to override the default function, which you don't really do very often. But I just thought I'd share that with you, in case one day if you're working on your own C++ projects, if you tell yourself, oh, I need to overload the simple assignment operator, actually, no, you don't, because it's done for you. Okay? So, the very next thing we gotta do. So everything that I discussed so far was overload functions for structs. Now it's time that we have to talk about overload functions for classes. Okay. Now, so writing overload functions for classes, it's very similar to writing overload functions for structs, just with a couple things that are different. So the first difference is that operator overload functions for classes require the friend keyword in front of it. And what this friend keywords means is that, well, I said it here. So classes cannot access friend functions, but friend functions can access classes. So by having the friend keyword in front of a member function, this basically means that it's associated with it, but it's not really like a member of it. For example, because overload functions are friend functions, inheriting classes can't get overload functions for the base class it's inheriting, right? Plus, you wouldn't want that to happen either. That would actually kind of like screw things up. But yeah, that's why you need the friend keyword in front of it, and then the other difference is the const keyword. So the const keyword is typically applied to ensure that when friend functions access member variables of class, they are not changed. Okay. Now this const keyword will occasionally put them in front of like data types to ensure that when a function is called, they are not being changed. Well, you'll see more when we get down to it. Now, if you look here at these last slides, so I wrote syntaxes for. This is the general syntax to overload binary operators for a class, and this is the one for relational operators, which always return a bool. And then I have the general syntax for binary operators for arithmetic or assignment operators. Now, because operator overloading is such a big nitty-gritty subject, there's actually way more than this, but I'm only showing you these two. And the reason why I'm only showing you these two is because these are the only two that we need in order to complete our student type.h and our faculty type.h. Okay? So here's one syntax, here's another. So in this slide here, here are 3 overload functions that we need to add to student_type.h so that we can complete our lab 3. So here's what we got to do. Overload the comparison operator for the student type class. And note, this is a relational operator. So it'll accept student type student1, student type student2. If first names, last names, and SIDs are equal, return true. If else, return false. Okay? Now, so after we do this, we would have completely finished our student type and faculty type classes. Okay? So here's what I would like you to do. What we need to do is open our lecture activity 7 and copy paste person type.h, student type.h, and faculty type.h. Okay? So open your file explorer. Go to the folder where you saved lecture activity 7, right here, and select person type.h, and holding control, select student type.h and faculty type.h. Copy these. Go back. Go to your lecture activity 8. Go into its project folder and paste everything. Okay? So now I have person type, student type, and faculty type. Okay? Now, go back to Visual Studio. Right-click Source Files. Hover over Add. Click Existing Item. And select those 3 files. So, person type, student type, faculty type. Click Add. And now I can open them one by one by double-clicking them. Here's person type, student type, and faculty type. Okay? So, here's what I'm going to do. I'm going to dock student type over here. And I'm going to open main.cpp over here. These lines of code that I put here, you actually don't need that. Get rid of those. I only put that there to demonstrate the simple assignment operator to you. But anyways, it's time to do parts 2a, 2b, and 2c. We write overload functions for these. So I'm going to see out. This is section 2a. And this is going to be called overloading the comparison operator for student type. Okay. So in order to demonstrate this, I think I need to declare, well, actually, the first thing I need to do is include those 3 header files into my main.cpp. So scroll to the top and include person type.h, include student type.h, and include faculty type.h, like that. Okay? So now I can access these header files now. So here's what I want you to do. We already know how to use a student type class, right? So declare 2 variables of student type and give them different names. So maybe student type. Let's call this student 1. Or actually, let's call it student A. Student A. And invoking the parameter constructor, we'll pass 5 variables to it, each of them being first name, last name, age, then SID, major, and GPA. So I'm going to write dummy variables here. So I'll say Bob Jones, his age will be 25. His student ID, I guess, will be 1, 2, 3, 4, 5, 6. His major, I guess, will be math. And his GPA, let's call it 3.6. Like that. And let's declare it student B. Type student B. Let's call it John Doe. Let's make him 28 years old. His student ID, I guess, will be 2, 3, 4, 5, 6, 7. His major, let's make his major history. And then lastly, his GPA is it's gonna be very low. Let's make it 1.8. Now, so here's me using the overload function. Well, after we write it, of course. So I'll say if student A equals student B. Now this is an error because I didn't overload this yet. I'll see out student A is equal to student B. But if that's not the case, I'm going to have an else here. See out student A is not equal to student B. Like that. Okay. So I have to write the overload function for this for student type. So go to your student type.h. If you recall from the PowerPoint, the syntax for the comparison operator is a relational operator, so we would use this syntax, right? So here's what we would write for the function prototype. Here's what we write for the definition. We would write friend data type, which is going to be bool because relational operators always return a bool. Then we say the operator which we want to overload. Then we use the const keyword because we don't want to change the member variables of the two operands in which we're accessing. And we would put const for both of them. And then we would put the address of operator in front of both of them because we need to reference them like directly. And then the definitions, like right here, it's almost the same except we put variable names in them. So here's what it would actually look like. So over here under public, let's write new comments. Overload functions for student type. Okay. And the overload functions, the syntax is going to be, it's going to be similar to this, actually. If I can just, okay. So I need the friend keyword first, okay? I need to say the data type in which I'm returning, and that's going to be bool. Then operator, then the operator I wish to overload. So bool operator equals equals, and I have to say const student type ampersand const student type ampersand. Okay. Now I'm going to copy this I'm going to go to the bottom and put it here. I have to, as you can see in the function definition, I don't have the friend keyword anymore. So we can go ahead and remove this friend keyword. Well, what we do need to do is remove the semicolon, add squiggly brackets, and then we have to give our variables names. Now, if you go back to the lecture activity, I actually told you to name them student 1 and student 2, well, stud 1 and stud 2, and then if first names, last names, and SIDs are equal, return true. If else, return false. So let's do that. So you are stud 1, you are stud 2, okay? Now, we want this to return true if first name, last name, and SIDs are the same, right? So if stud 1 dot first name equals stud 2 dot first name and stud 1 dot last name equals stud 2 dot last name and stud 1 dot SID equals stud 2 dot SID. If all of this equates to true, we will return true. But if it's not true, else, we will return false. Okay, so this is the first overload function for student type. Now, keep in mind, I defined this overload function to only look at first name, last name, and student ID. Now, the reason why I chose to do it like that is because in your lab 3, lab 3 has a feature where you can add new students to the student vector, but it checks to see if a student of that if a student with that first name, last name, and SID already exists. And if it checks to see if they exist, it won't add it because it's not going to allow copies. And that's why I only accounted for first name, last name, and SID, even though there's 6 different private members that student type has. And the reason for that is because let's say a student changed their major from math to history or English to art or something like that. They would still, even though those entries would be different, they would still be considered the same student. So that's why I only decided to check 3 variables instead of all 6. Okay? But now that we have this now, we can actually go back to our main.cpp and see if this works. So because first name, last name, and student IDs are not the same, what should happen as a result is that this code is ignored and then this code executes. And I'm going to have a cout and line here so that we have some room. Yeah. Student A is not equal to student B. That's a fact, okay? So that's the first overload function for student type. And what's next actually is going to be that we're going to have to overload the greater than or equals to operator and then the less than or equals to operator. Now, the way that I wrote these overload functions is that it'll take the second operator is going to be a double, and it returns true if student1.gpa is greater than d, return false if else, and then same is true for the inverse. Takes a d, and then returns true if GPA is less than d, else if else, return false. Okay, so I'm going to go through these very quickly. So because of this is going to use this syntax here, okay? Where we're going to have our friend keyword again, the data type, and then we're going to have, we're going to use this syntax here, okay? So I'm going to go back to our student type.h. Go to where your public is, and then let's create the prototype for the next overload function. So friend, now because comparison operators return bools, this is going to be a bool operator. Now this needs to be greater than or equals to, because that's the operator in which we're trying to overload. Okay, so we're going to have const student type ampersand in front of it. Now the second operator for these particular overload functions, they're not going to be a student type, they're going to be doubles. Okay, so I'm going to have a double there instead. The same is true for the other overload function. So friend bool operator less than or equals to const student type ampersand double, like that. So here are the function prototypes, because remember, operator overload functions are just functions. Okay, we're going to take these, copy them, scroll to the bottom, put them here, remove the friend keywords, remove the semicolons, add squiggly brackets, and we actually need to give them names, so we will call it this one student1 again. The double, we'll just call it D. Well, we'll call this one student1 again. We'll call this double D. Now they have to return true or false. Okay. So it accepts a faculty. Oh, wrong one. It accepts student type student1 and a double. If student1.gpa is greater than D, returns true. If else, returns false. Okay. So if student1.gpa is greater than or equal to D, return true. If this is not true, else return false. Okay. Now the definition for this one should be almost exactly the same. So I'm actually gonna, it's gonna be very similar to this. So I'll just say if student1.gpa is less than or equal to D, because that's the way it has to be. It has to be. So this one's greater than. This one's less than. Don't make the mistake of mixing them up. So I'm gonna have a if statement here, return true, and then if this is not true, else return false. Okay. So those are the two overload. So these are the three overload functions that we need for student type.h. So let's go back to our int.main and demonstrate them. So cout, this is going to be 2b. Overloading greater than or equals to for student type. Like that. So there's actually no need to declare new student types because I already declared variables here. But here's what I'm going to do. The way our lab 3 works is that it uses the overload function for greater than or equals to or less than equals to measure a student's GPA. If a student's GPA is above 3.5, they're on the dean's list. But if a student's GPA is lower than or equal to 2.0, they're on academic probation. So that's why I use those particular overload functions, okay? So I'm going to say if student A, and that's referring to this one here, right, is greater than, and I'm going to have a greater than or equals to, and I'm going to have a double here. I'm going to say 3.5, like that. Oops. Didn't mean to do that. If student A is greater than or equal to 3.5, and remember, this calls this particular overload function, right? We'll see out student A is on the dean's list. Okay. See out line. And then lecture activity part C uses the less than or equals to operator. The way lab 3 works is that it checks students' GPAs and see if their GPA is lower than 2.0, okay? So let's have another section here called C out. This is part 2C. 2C. Overloading less than or equals to for student type. Right? And this time I'm going to use student B. If student B is less than or equal to 2.0. Now this checked this. By doing this, I'm calling this overload function, okay? It'll return true if the GPA is less than 2.0 and false if that's not the case, okay? So if this is true, I'm going to see out student B is on academic probation. Like that. Okay? So save that. So this is 2A, 2B, and 2C. So if we ran it now. Okay, so because student A's GPA was 3.6, and because 3.6 is greater than 3.5, this actually C-outed. And student B's GPA is 1.8. And because 1.8 is less than 2.0, it's C-outed student B is on academic probation. Does that make sense? Okay, so that's the so those are the 3 overload functions for student type.h. The last thing we need to do is write the overload functions for faculty.type.h. Okay. So these are the overload functions that we need for faculty type. But the first thing I'm going to do, I'm actually going to stop for a second. I'm going to zoom out so you can see everything. So this is everything that we wrote for student type. Here are the operator overload prototypes for student type. There's 3 of them. And then here are the 3 operator overload function definitions that we wrote, okay? So make sure you get that if you need that. But anyways, it's time to do the last 3 overload functions for faculty type. So let's make a new section. See out and line. So faculty type. So we need to overload the comparison operator. It accepts faculty type fac1 and faculty type fac2. If first names and last names are equal, return true. If else is false. And then the overload functions for plus equals and minus equals. This will change the salary for faculty type. It accepts a faculty type and a double D. So it either adds to salary or subtracts from salary. Okay? And these are the functions that our lab 3 needs, okay? So escape. I'm going to close student type.h because we don't need it anymore. And I'm going to dock faculty type.h over here to the side. So over here in public for faculty type, add a new comment. These are the overload functions for faculty type. And I know you're tired like I am, so I'm just gonna give them to you, okay? I'm not gonna like explain it too much. So I'm just gonna type it all because we already made overload functions for student type, and you already know the process. The syntaxes are in the PowerPoint if you need to refer to them. So I'm gonna write this now. So here are the prototypes: friend, bool, operator, equals, const, faculty type, ampersand, const, faculty type, ampersand. So that's the first overload function. The next one is going to be the plus equals operator. So friend void plus equals, because the plus equals operator doesn't return anything, so it's going to be a void. Well, I have to put the operator in front of it like that. You'll accept faculty type, ampersand, and a double. Now keep in mind that I don't have the const keyword in front of here because I'm directly changing the faculty's salary. So because of that, I can't have the keyword const in front of it, because this makes it so that member variables are unchanged, and I actually do want to change member variables. So this const word, do not put it in front of this one. But anyways, friend void operator minus equals, you'll accept another faculty type, ampersand, double, like that. Copy these, scroll to the bottom, paste them here, delete these semicolons, delete the friend keywords, and add squiggly brackets, okay? Now these definitions are even shorter than the ones for student type, so here's what I'm going to do. Well, I actually have to give names to these variables, so let's call you fac1, and you call you fac2. For this function, we'll give these names fac, for short for faculty, and then double D, and then we'll do the same here. FAC for faculty, and then double D. So if fac1 dot first name equals fac2 dot first name, and fac1 dot last name equals fac2 dot last name, like that, we will return true. If else, return false. That's the first definition. The definition for this one's even shorter. All we're doing is adding D to the salary. So fac.salary plus equals D. That's it. And then over here, fac.salary minus equals D. So these are the 3 overload functions that we need for the faculty type class. I'm going to zoom out. Here are the prototypes, if you need to see it. Here are the definitions if you need to see it. Okay? So now it's time to create sections in our main.cpp so that we can finish this. So cout, call this 3a. Overloading double equals for faculty type. Now this time, we have to declare 2 different faculty type variables. So I'm going to say faculty type faculty A. And the variables are going to be sorry, one moment. So for faculty A and B, for the faculty A, why don't you just use me? So put my first name, Lawrence Orijuela. My age is 25. My discipline is computer science. My salary, I'll just put a fake salary. Well, let's put that, okay? And for faculty B, I'm actually gonna use my project advisor, okay? So faculty type faculty B. My project advisor is Professor Gomez, so I'm gonna say Ernesto Gomez. I'm not gonna give you his real age. I'm just gonna put 50. His discipline is also computer science. His salary, his should be a lot greater than mine, so I'm just gonna guess what it is. Okay. So this is me using the comparison operator for faculty types. So if faculty A equals faculty B, I'm allowed to do this because I overloaded the comparison operator. Cout faculty A and faculty B are the same, but if they're not the same, I will have an else. Cout faculty A and faculty B are not the same. Like that. Okay? So that's part A. Yeah, I'm going through this fast because I think you guys get the point. So, cout. This is going to be part 3B. Overloading plus equals for faculty type. So I'm going to use faculty A for this. So the way that I overloaded this, the plus equals operator, is that it takes a double D and it adds or subtracts that much from salary, okay? So let's say, for instance, I'm going to cout faculty A's salary faculty A dot get salary like that. But then I'm going to use this overload operator to add to it, okay? So right now it's 80,000. But if I said faculty A plus equals, let's say I did a really good job as being a professor and they decided to increase my salary by that much. But that's just wishful thinking, you know? So, what should happen as a result is that this 2,000, this 20,000 gets passed to D, and then it gets added to faculty.salary. And to demonstrate that, I'm going to copy this line, put it here, I'm going to say after increase like that. So what should happen as a result is that this 80,000 gets added with 20,000 to make 100,000, and so I should see the figure 100,000 in here. Okay. So it used to be 80,000, now it's 100,000. But let's say that I did a very bad job as a professor, and they decided to decrease my salary. So I'll say C out. This is going to be section 3C. Overloading minus equals for faculty type. And I'm actually going to copy this code again. But instead of plus equals, I'm going to say minus equals. And let's use a different number. Let's say 30,000 instead of 20,000. So let's see what happens as a result. So faculty A's salary used to be 100,000, but by minus equaling 30,000 to it, we called this operator overload function and subtracted 30,000 from the salary, okay? So as a result, 100,000 minus 30,000 is 70,000. But anyways, this is your entire lecture activity for this week. So I know that every lecture activity that we did in regards to classes, they were huge, but I had to do that in order to teach you everything that I needed to teach you. But now that we are officially done with overloading, all of the remaining lecture activities, they're going to be short from now on. So thank you for sticking with me this far. And here's actually the best part too. If you have everything, your person type, your student type, and your faculty type, you have everything you need to do Lab 3 now. And I'm actually going to release a video showing how to assemble your Lab 3 later. So keep an eye out for that. But anyways, here's what I'm going to do. I'm going to zoom out so you see everything. And I'm going to scroll down very slowly in the main.cpp so that you see everything. So here's your main.cpp. Pause it whenever you need to in order to get everything. Your person type.h is unchanged, so I'm not going to show that. But I do need to show you student type.h. I'm going to scroll down very slowly so you see everything. So pause it if you need to fix any mistakes. But yeah, we just officially finished classes. So here is faculty type.h. I'm going to scroll down very slowly. Okay, great. So you should have got everything. So you already know what you have to do in order to turn this in. run this program once more. Get a screenshot of everything. Okay. So, and then pull up your email. I'm going to have mine here. Send it to me. This is CSE2000Q2S. First name, last name, first name, act 8. Put your screenshot in the body, and this time I need 5 items from you. First one is a screenshot, and then the other files is going to be your main.cpp, your person type.h, your student type.h, and your faculty type.h. So attach those. After you attach all that, email it to me and I'll give you your grade. Okay. But now you should have everything you need to do lab 3, and I'm gonna show you. I'm gonna release the video on how to do that as well, so keep an eye out for that. But anyways, this is it for this week's lesson. I hope you learned everything that we need to learn about overloading. But yeah, so anyways, that concludes this week's lesson, and I will see you next week.